not working. Good afternoon. My name is Sean Magann. I'm the Chief Commercial Officer at Sims Lifecycle Solutions. I'd like to introduce my colleague, Chris Fox. Chris is the Chief Operating Officer at Sims Lifecycle Services. If you don't know who we started as a ferrous and non-ferrous metal recycling company. So we were on the back end of the recycling chain. Since then, we moved upstream. So we started with doing ITAD and asset management services, and now we're really big into the redeployment side. And so I think our presentation fits very, very well with some of the points that the previous speakers have made. If you look, our business, it's been pretty traditional, right? In the server space, folks would build the data center equipment. Folks would use it. It would come to a company like Sims to decommission the material. We would harvest parts, and then we would recycle the rest. Pretty straightforward, pretty much a linear process. There was some circularity in the sense that some parts were harvested and resold, but generally speaking, those were sold to brokers building other generation of hardware. Now, we knew redeployment of used materials into new kit. It's always been a great idea. It's been a great idea from a financial standpoint, and it's been a really, really good idea from a circularity standpoint. But everyone wanted new kit, right? They wanted new stuff and new components to go into their kit. And so for many, many months, many years, I should say, people like our company in the industry really tried to push the integrators to use more and more redeployed equipment. But there was a bit of resistance. So what happened in 2020, as we all know, COVID hits, right? And we find out that the supply chain isn't so resilient. And so where we had a just-in-time scheme, now everything was just in case. There wasn't enough components to build new materials. And so some of the large hyperscaler customers came to our company and said, well, all those ideas we had in the past about redeploying and using second life materials into our new kit, we want to revisit that now. It seems like a good idea. Again, it's always made sense, but it makes even more sense when you couldn't get new material. So what we did is we started working with these same companies, many of the companies here at the OCP, on a similar process flow with one caveat. On the decommissioning phase, some parts would still go for resale that you see, but a lot of material would go back and be redeployed back to the actual folks manufacturing the kit for themselves. It would be as either critical spares or to go into new servers. But it changed our business model because in the past, the people buying the reused components weren't necessarily the same people that were using in the first instance. And so in many ways, we became a manufacturing company. We weren't just an ITAD recycling reuse company. We've had to move to become a manufacturing facility, which was new to us, right? And we faced two big challenges as we pivoted from just a take-it-apart company, if you will, to a manufacturing company. There were two major obstacles we had to overcome. Number one was scale, right? There's a lot of material out there. A lot of companies were asking for huge volumes of material. So we had to make sure that we could scale, but we also had to adhere to the quality standards of new equipment. Again, the people sending us the material want it back, and they want to make sure that the quality of the material they get is just as good as it was the first time. So that put a lot of challenges on my colleague, Mr. Fox here, and he'll talk a little bit about how we overcame some of those challenges.
Yeah, thanks, Sean. So I think the reason why scale and quality became the two biggest challenges we had was, one, because the end of the linear supply chain that Sean spoke about earlier, it was very supply orientated, right? As the data center needed to clear out, then the supply of material would dictate what capacity was needed to take it. But when you look at it and you spin it on its head and you look at how you link two linear supply chains into a circular supply chain and the forward movement of some of that redeployment, then you've got two competing requirements. You've got the decommissioning of equipment, which is driving supply, and the demand side for new equipment going into new build. So for us, in terms of flexibility became really, really important in the sense of how do we accommodate those two things, and how do we do that within the maintenance of a quality-led environment where essentially the equipment that you're taking on the end-of-life route is really needing to adhere to standards of the forward route for new equipment going back into the data center environment. So for us, the focus really became about automation. You know, it shouldn't be any surprise, you know, the macro challenges that are faced around the world at the moment in terms of sourcing people and inflationary pressure that go around that. To have a flexible model that allows you to ebb and flow depending on the requirements of, you know, the supply side factors or the demand side factors has drove us to really work with our partners and across the OCP in the sense of driving automation into the circular economy. So I think speakers before us have made the case for circular economy within this type of equipment very strongly in the presentations. Professor Andrews spoke about it earlier on. You know, so I'm not here to convince anyone why this is important. What I'm here to talk about is how we have tried to overcome the challenges we've just been alluded to. One of the key things for us is around the technologies that we're implementing into our facilities is really around and how we drive automation. The first thing we had to do was look for a digital twin to really bring this to life. And what that is, often to drive automation, what integrators need is access to the data, not necessarily access to our systems. And we've got a lot of equipment coming through in lots of different configurations, lots of data points, and therefore for us to replicate our operations digitally allows us to really move forward those automations at a faster pace. We don't have the slowdown of having to figure out how we link various types of automation into our systems. We can replicate our data, and we can use that to drive automation into our facilities quicker. The last point on the bottom arrow there is around work activity. One thing we found with the supply chains regarding equipment coming out of data centers, they can be highly variable. And therefore, when it comes to planning work activity and planning capacity, a opportunity to be able to map that and see what that looks like and resource it accordingly has been really critical. So the implementation of a digital twin for us to really see our operations in a digital line and as well as a physical line has been really key. But from that, when we've assessed that, what are the technologies that we are now implementing in terms of how do we bring capacity to the circular economy? And these are the things that we're really focusing on. I think in some of the presentations earlier on, you heard a lot about asset traceability and having visibility of where parts and components come from, when they came in, what new equipment they go into. And we're implementing through our facilities RFID, which allow us to quickly speed up access to that data. So we, this year, were successful in redeploying over 1 million DIM units back into the data center environment, into a live environment. And when you have to have the traceability of where all that equipment came from to be able to justify that back, technologies like RFID are key. The quality aspect we talked about before, again, historically you would look at the reverse supply chain as being quite coarse, right? The processes around it are very manual, but you can't link that then with the quality steps needed to put equipment back into a data center environment. So we've been harnessing AI and machine learning to really speed up the steps that we do around quality assurance and quality checks in line with our clients' requirements and their models. Anyone will know when you decommission a rack fully, there is the rack in itself is one big monolithic piece, but when you take it down to its constituent parts, there's a lot of different types of equipment in there that require moving in different ways. We are using industrialized mobile robots to move a lot of this equipment through our facility. The benefit there is not just in the savings that gives us in the people resources we use, but also from a quality-led perspective as well. The clients we're working with are very prescriptive about how equipment that goes through the circular economy, how it should be handled, the way it handled, and we're finding that the use of IMRs is really advantageous to that. And then finally, the technology which we're really putting a lot of effort into, and there is a lot of overlap with the OCP in this, is the area of cobotics. Our aim is to really touch this material as little as we possibly can with human hands, and working with people alongside automation when handling components and the equipment within some of these servers and networking equipment is really key. Using the digital twin in a combination of these cobotics has really allowed us to increase capacity. So the scale that Sean was talking about earlier on, in some of the areas where we've implemented this, we've seen capacity increases of over 60% just by implementing the technology itself. So all of these are tools that we focus on in terms of priority of need. They're extremely linked into our clients' quality requirements, because ultimately, all this work that we do, unless that component or that part or the server itself can go back in to a live environment, then it's all wasted, and the circular economy kind of stops dead there. But they have to be flexible, because one of the things we were talking about earlier is those different supply side and demand side kind of parameters and inputs that requires us to have flexible solutions. So just a bit of simulation that we've got from some of the work that we do with our digital twin providers. You'll see here, a very kind of static, some of the work that I think Professor Andrews was talking about earlier on, which is where, we're taking components out, some are going for reuse, some are going for recycling and things like that, and very, very manual and very, very capacity constrained. And the work that we're currently implementing now in our facilities in the US, really with the link of automation, and it's this area here at the back where you see the yellow virtual people, where we've just with the introduction of automation, we've managed to increase capacity by over 60%, which is key, because if everyone here moves to a circular-based approach, then at that point, it's companies like ours and other industry partners that need to create that capacity within the circular economy to make it work.
And just in summary, well, just to touch on a point Chris made in terms of quality, at the OCP just the other day, we spoke with a vendor that was doing very similar work with a very similar customer, but they were handling the material as a teardown company would, right? They're not putting the same type of manufacturing quality. And so a similar project, not exactly apples for apples, but a similar project where we're having quality of 99.1%? 99.6? So it's pretty good. The same vendor doing something similar said they would be lucky to get 50%, right? And it's not that they were doing anything wrong. They were just handling it like we would have 2 years ago as a dismantler, right? But again, by looking at ourselves as a manufacturer and treating the material differently, again, there's 101 variables, right? So it's not a like for like, but it's a huge uplift. So what did it mean? So what does this all mean? Last year, millions of components were redeployed to build new racks or used for critical spares. Chris mentioned 1 million. I'll correct you, my friend, that it's actually 2 million we did this year, right? 2 million DIMMs that would have gone into the marketplace, and who knows what would have been done for them, went back to a hyperscaler. They put into new kit, right? Depending on who you talk to, the hyperscaler itself estimates that each DIMM of memory is 12 kilograms of carbon to manufacture. So you manufacture, or you multiply that by 2 million sticks, it's a big number. And so we're very pleased. We think it makes economic sense to do this. We think it makes environmental sense. And we're very, very pleased to be in this ecosystem, working with everyone here to see what we can do to get kit back to its original use. It can be done. It can extend the life of product. And I think it sounds cliche, but it really, really is a win-win situation from an environmental, financial, and from a resiliency standpoint. With that, we'll open up for any questions.
Quantify the robotics aspect of what you're doing, kind of, the number of, I guess, how would you quantify how much more robotic you are now versus 2 years ago? In terms of reduced labor hours or however you...
Yeah, the short answer is infinitely, because 2 years ago it was very little. I think data off the top of my head I've not got, but I think what I can say is that that capacity increase of over 60%, if we had access to the equipment, would be done on a very similar labor profile to what we have now. That is a bit nuanced in the sense that part of the labor associated with that would increase in one area of our facility, but would significantly decrease in another. So we see it very, very relevant to certain steps of the process, more in the back end of where we're focusing on redeployment, in opposed to the front end, which is just very associated with handling and configuration of the equipment to get access to it and all those type of things.
Wouldn't you say it's complicated to answer that because we've been on a consistent scale up, right? So we haven't had a consistent volume of material. So it's kind of hard to make those assumptions, but it's, to use a technical term, it's been a huge benefit, so.
Yeah, it's clearly a very short ROI, or the ROI is absolutely clear.
Yeah, sure.
Thank you.
Questions? All right. Well, thank you. And again, we apologize earlier for some of the technical issues we had, but it looks like we got it sorted out. So thank you.
Thank you.